Alright, so Year 8 we're going to be doing some harder examples today for area of a circle. So looking at this first question, it says a circular tree trunk has a cross-sectional area of 454.4 centimetres squared. So that means we have the trunk of the tree, which is basically like a cylinder. But if we cut it, slice it, cut the tree down, that piece there, if you look at it, will be a circular shape. So we're going to assume it's a proper circle. Alright, so because of the word circular and the word area in the question, we're writing down the formula for the area of a circle. So we do that first. Area equals pi r squared. Now, they've given you what the area is. You're not finding it, they've given it to you. So we're going to put this number in place of A. Now, we don't know anything else, so we just got that equals pi r squared. We've been asked to find the radius. So that means we have to solve a little equation here to get the r by itself. So the first thing that we need to remove is the thing that's not the best friend of the r. So which one is more attached to the r? Is it the pi or is it the squared? Well, I'm telling you, any power like that is very strongly attached to the r. So we're going to leave the squared with the r, that's like its best friend, it's staying together. And we're going to get rid of the times pi. So we're going to the other side and we're going to do the opposite of times, which is divide by pi. And it will look like this. Okay, and then over here on the right hand side we still have r squared sitting there. So at that point we go to our calculator. So you're going to get your calculator and just press in what we're looking at on the left hand side here. So we're going to do fraction key, 454.4 on the top, down arrow, and we want pi on the bottom. So we're going to do shift pi, and there it is, press equals, and write that down. Okay, now, we still have not got r by itself. Don't get rid of that answer on your calculator, leave it there. So we need to get the r by itself, so that means we have to get rid of our squared here. And the opposite of squaring is square root. So we're going to come over here and square root this number. Now, if you go to your calculator now, I've still got that last answer that we were dealing with there. So now we want to do square root of that answer, right? So I'm going to do square root and then press the answer button, which will bring up the last answer we were dealing with, and then press equals. Now that's the answer I've already worked out and it's down there. Okay, now the question says they want it to correct 2 decimal places. So draw your red line after 2 decimal places. Look at your next digit. That next digit is 5 or more. So the one before the line will go up by 1. So this will become a 3. And copy everything else in front of it. Okay, and because it's in centimetres squared, we're giving our answer in centimetres because it is a radius. So we're just wanting the length of the radius, it's not an area. All right, now in number 2, the area of a DVD is 113 centimetres squared. Now I don't know if you've seen a DVD, but it's a circular disc. So they are assuming you know that a DVD is a circle. So we're dealing with the area of a circle, so we're writing the formula down. Now they want us to find the diameter, and we don't even have diameter in this formula. But we can find the radius. We've just worked out how to do that over in the other question. So that's what we're going to do to start with. So the area that they've given you is 113. So in place of A, we're going to write 113 and copy what we've got over here. Now, just like we did on the last question, we're going to get rid of our times pi. So come to the left-hand side and we're going to divide by pi. And on the right-hand side, we're left with r squared. Okay, so if we do that on the calculator now, So you know what to do. Just press your fraction key. 113 on the top. Down arrow, shift, pi on the bottom. Press equals, and you'll get that. Write it down. Okay, so now we're trying to find r. So we've got to get the r by itself. Don't clear your calculator, just always leave it alone is what you've just done. We're getting rid of our square. We're going to do the opposite operation over on the other side, which is square root. And our calculator still is sitting there with that number. So now we want to do square root of that 35 point whatever number, which is what we've still got on our calculator. So we're doing square root, press the square root key, answer, and it'll square root the last answer you had there, which was the 35 point whatever, equals. And I've already written that answer down. Now, keep that on your calculator. Just always keep your last answer because you never know when you're going to need it again. All right, so now we've got to find our diameter. The diameter is double the radius. So we have to get our radius and times by 2. Okay, to get a radius, you're going to do that. To get the diameter, you're going to get the radius and times by 2. So then when you do that, all you'll have to do is, we've already got that on the calculator, so all you're pressing is times 2. So we press times 2 equals, and you'll get the answer that I've already written down here. And now we're doing our rounding off. And this question wants 1 decimal place. So we're going to draw our red line after 1 decimal place. Now that next digit is a 9, that's 5 or more. So this will go up by 1. Now, putting a 9 up by 1 has to go to a 0. It hasn't really gone up by 1 at all. So that's when you have to put the next digit up by 1. So that will become a 2, and then copy everything in front, and it's in centimetres. So our answer is 12.0 centimetres. That's our diameter. So as you can see, there's a lot of decimals that we're writing down here. You do not do any rounding until the final answer. Okay, so I know it's a bit tedious writing it all down, but no rounding till the final answer, because sometimes it will throw your answer out by 0.1 or something. Okay, so one of the biggest mistakes in the HSC is doing early rounding on questions. You never round till the last line. Okay, now this next question here, we're finding the area for all these things over here correct to 2 decimal places. So here's our first one. It's a composite shape. It involves 2 different shapes here. So up the top we have a triangle, and down the bottom this is a semicircle. If it looks like a semicircle, it will be. So we're going to start with our semicircle. I always like to start with the thing that's got the curve in it. Get the harder bit out of the way first. So a semicircle is half a circle. So we're going to do half of pi r squared. So the area of a circle is pi r squared, but a semicircle would be half of that. Okay, so we're going to sub in. We've got a half times pi times, don't forget you have a times in here. Now, the radius of the circle that the semicircle is part of, this would be the radius. Okay, that's your radius there. Now that radius, the 9 is the whole way across, so the radius will be half of that. So we're going to do 9 divided by 2, and that will give you 4.5 for your radius. Okay, so we're going to put the 4.5 in here for our radius, and then you're going to put that in your calculator, the whole thing in your calculator. Okay, so to enter it, we will be pressing fraction key, 1 over 2, 1 down arrow 2, right arrow out of it, times. We want pi now, so it's shift pi times, then we're doing 4.5 squared. So 4.5, now to get the squared up there, it's the x squared up the top here, press that, should look like that, and then you can press equals. And the answer is 31.8. And here it is. Okay, so make sure you get that answer. All right, next thing, we're looking at the triangle at the top. Now you do need to know all your areas for all your different shapes. Okay, so the triangle area is a half base by height. So now we're subbing into this. So it's a half times, and the base of the triangle is 9 all the way across, times, and the perpendicular height of the triangle is 12. Right, so you're just going to work that out. A half times 9 times 12 on your calculator. You will end up with 54. And now we want to do the total area. So we're going to add the area of the semicircle and the area of the triangle together. So that's what I've written here. It's this answer plus this answer. And if you add them up, that's what you're going to get. So now we're up to the rounding, which they wanted 2 decimal places. So let's draw our line after 2 decimal places. Now that 8 there after the line is 5 or more. So the one before the line goes up by 1 and becomes a 1. Everything in front of that, copy. Okay, now it's in millimetres. And we're doing an area, so it's squared. And that's your answer to the question. So there's a fair bit of working here. So you're going to have a few marks attached to these questions in a test. All right, so show every step of your working, always start with your formula. Okay, now in B, we're finding the shaded area. So the first thing we're going to do is find the area of this square here. Now, how do I know that's a square and not a rectangle? Well, they've given me 10 for that side and 10 for that side. So I know the sides are all equal. So I'm going to write down the area of a square formula, which is area equals S squared. If you want to do it as a rectangle, you can. Alright, now the side length of the square is 10. If we square that, use your calculator if you like, and get 100. Okay, next part, we're going to work out the area of this circle here. So the area of the circle formula is pi r squared. And now we're going to sub in our radius. Now let's have a look at this and find out what this radius is. Doesn't look like they've given you a radius here. But if you think about it, just get your red pen, put the centre in, that's our radius. Now how big is that? Well, I hope you can see that that distance across the circle will be the same as this, so it's going to be 10. And that's just half of that distance. So that's got to be 5. Right, so we're going to put a 5 in for our radius. And then if you put this in your calculator, shift pi times 5, press your x squared key, equals, you'll get that answer. Alright, now we're looking for the shaded area. So what we're actually doing is we've got the area of the square, which is the whole inside of that square. Then we've got this area of a circle, which we're going to cut out and remove and throw it away. And when we do that, we'll be left with these little bits that we want. Okay, so because we're taking an area out and throwing it away, we're subtracting. Okay, so we're going to have the area of the square, which is 100. Take away the area of that circle and throw it away. If you work that out on your calculator, you're going to get the answer I have there, 21 point whatever. Okay, we're now rounding to 2 decimal places. So draw a line after 2 decimal places and circle the next digit. That digit I circled is less than 5, so the digit before the line will stay as a 6. Everything else in front stays. And then we've got centimetres and it's squared for area. Okay, next question. We're finding this shaded area here. Okay, so we're going to start with finding the area of the big circle. Alright, so the area of a circle is pi r squared. So we're doing pi times. Now, what's the radius of the big circle? Well, I hope you can see that going from there to there is the radius of the big circle. So it's 3.2 squared. Now, if you put that in your calculator, that's the answer you'll get. Now we're working on our two small circles, these little ones here. So if I do them together, two circles will be 2 times the formula for one circle, which is pi r squared. So now we're going to sub into that. We have 2 times pi times. Now, what is the radius of the little circle? Well, here's the radius of the little circle. I'll do it with the blue pen. How big is that? Well, that has to be 3.2 halved, or 3.2 divided by 2. So just write it wherever you can fit it. 3.2 divide by 2. Use your calculator and it will give you 1.6. That's the radius we're putting in there. Don't forget we're squaring it, so we've just got to put our square here. Now if you put all that in your calculator, 2 times shift pi times 1.6, press the x squared key, equals, you'll get that answer. So how are we going to find the shaded area? Well, we're going to start with the big area, which is all of the stuff inside the big circle. Then we're going to get these two little areas, cut them out and throw them both away. That means we've got to take those areas off. Okay, so we're going to start with our big circle area. Write that answer down. And then we're going to take away the two little circle areas, which is this answer here. And then if you work that out on your calculator, that's the answer you're going to get. Now something interesting has happened, hasn't it? So the answer we ended up for the shaded area was exactly the same size as the area of the two little circles. So that's something that is an interesting concept that we're not going to do right now because you probably won't cope with it. But it's something that Newman might like to think about when they're sort of investigating some of these things. That's some of the sorts of things they might look at. Okay, now we've still got to round this to 2 decimal places. So we're going to draw a line after 2 decimal places. Look at the next digit. That's less than 5. So the digit before the line will stay as an 8. And copy everything before it. We're in centimetres. And it's an area, so it's squared. Okay, now this last question here is also looking at a shaded area there. Now it looks a little bit like a donut, but a donut has a hole in the middle. This has a hole in the middle. But the difference is that a donut is a three-dimensional thing, okay, and this is not. This is 2 concentric circles. So for those of you that aren't sure about what that means same centre. So if you look at these 2 circles here, they share the same centre point. All right, the smaller circle has that centre and the bigger circle has the same centre. Okay, so they're called concentric circles. Now the shaded area between the 2 concentric circles also has a name. It's called an annulus. Now at this stage you're not going to be expected to know what that is, but just know it's the shaded bit between the 2 circles if you can remember it. Alright, so I'm going to try and do this all in kind of one go. So we know that we're going to do the area of the big circle, and that would be the area inside the whole big circle. Then we get the area of the little circle, cut it out and throw it away so we're left with what we want. So this is the way I'm going to do it. I'm going to write it down like this. That's pi r squared for the area of a circle, and I've put a capital R to say that's my big circle. And then I'm going to take off another pi r squared, but this time I've used a little r because that's the little circle. Okay, now if you can't cope with this, you can do the 2 areas separately if you like and go from there, but I thought I'd do it a bit differently this time. Alright, so let's sub in. We've got pi times. Now, the radius of the big circle. Well, it goes from the centre all the way out to the edge of the big circle, so your radius is 7. Don't forget the square, minus pi times. Now, the little radius is the radius of the little circle, which is 5.5. And put that in. Don't forget the squared because we're following the formula. Now, if you put that in your calculator, left to right, don't press equals till you get to the end. That's the answer you'll get. Now we're rounding to 2 decimal places. That circled digit is less than 5, so the number before the line will stay as a 0. Copy everything before that. And we're dealing with centimetres, and it's squared for area. Okay, so that's the end of this part of the work in this video. In the next video for today's lesson, we're going to move on to doing perimeter of a sector. So come back in the next video to look at that work.